Welcome to video 6.5 on the percent yield. In this video, you're going to learn the concepts of theoretical yield and actual yield. Then you will also be able to calculate the percent yield in a problem. So the key vocabulary terms are actual yield, theoretical yield, percent yield, and these terms will be covered in this video. So when we do our conversion problems, when we do our stoichiometry, so far we have been calculating the amount of product. When you calculate the amount of product in a conversion problem based upon the chemical equations, you are actually calculating the theoretical yield. This is, in theory, how much we should get from a reaction. So if the whole world was perfect, if we never lost any mass or made any mistakes in the laboratory, whatever we calculate on pen and paper based on the stoichiometry and our chemical equation, that is our theoretical yield and what we should get in theory. However, in real life, when we go into the laboratory and we do an experiment, sometimes those numbers don't match up. And so what we produce in real life within the lab, that is called our actual yield. So the actual yield is what you get in real physical life. The theoretical yield is what you calculate on paper. And these numbers can differ greatly based on how well you perform a lab. Do you have good lab skills? Do you have good equipment? Or are you losing product somewhere? And so it's essential for chemists to understand and to use the concept of percent yield. This just shows you the relationship between the theoretical world and the real world. What you actually got in the lab versus what you should have got in theory based upon your math and your pen and paper. So the equation is pretty simple. We're just going to simply plug and chug these numbers in. However, I want to make you work to get a few of these numbers by doing some stoichiometry. But if it was just simply given to you, you would take the actual yield, what was found in the laboratory, then you would divide it by the theoretical yield, what you calculated on the piece of paper through your stoichiometry, times it by 100, and you would get your percent yield. So again, actual over theoretical times 100. Actual is what you get in the lab in real life. Theoretical is what you calculate on paper. You've already been calculating theoretical yield through the last few problems or last 3 homework assignments. The actual yield will always have to be given to you, or you'll have to be doing the lab in real life. So this value should always be given to you in the problem. So here we go. Let's get started. I'll show you a problem, and then you can try one on your own. So if you have 4.50 grams of HCl and it reacts with 15 grams of calcium carbonate, according to the following balanced chemical equation, calculate your theoretical yield of CO2. So we're going and looking for this guy right here. So we already know that your equation that you're going to be using is your actual yield divided by your theoretical times 100 to give you your answer in percent. So I need to determine my actual, my theoretical, and plug it in. So if 2.50 grams of CO2 are isolated after carrying out the above reaction, calculate the percent yield of CO2. So what they're trying to tell me here is this is the actual yield. This is what you found. This is what you isolated. This is what you derived after carrying out this reaction in a lab. So as I go to set up my problem down here, we would actually put 2.50 grams on top, and then we're going to come back, multiply it by 100 once I calculate my theoretical. So now how do I calculate and come up with my theoretical? Well, that's kind of like what you've been doing in the last few assignments. You need to do 2 stoichiometry problems, predict your product, and whoever makes less is what you will use. So because I've been doing it, I'm going to go ahead and set this up as scenario A and B. I see I have 4.5 grams here, and I have 15 grams here. The product in question is CO2, so I like to put a question mark here. And of course, these need to be in grams because I need it to be in grams down here when I go to do my calculation for the percent yield. Okay, so let's get started. 4.5 grams of HCl. Follow those units. We know we can go from grams to moles of HCl. Now I'm going to go from mole of HCl to mole of CO2. Now I'm going to go from mole of CO2 to grams of CO2. As I go through here, if you look at your periodic table, you would find that this is 36.46 to 1 mole. Looking at your conversion problem, you see you have a 2 to 1 ratio, 2 to 1 or 1 to 2. And then again, look at my periodic table, 1 to 44.01. If you plug that into your calculator, you're going to come up with 2.16 grams of CO2. So in scenario A, I came up with 2.716 grams. Now we need to do it again for scenario B. Scenario B, 15 grams of calcium carbonate. Follow those units. Follow those units again. Then I'm going to go from calcium carbonate to carbon dioxide. And then my last conversion factor, carbon dioxide back to grams of carbon dioxide. Go through, fill in your numbers, 44.01, 1 to 1. And then here again, look at your periodic table. This would come out to 100.05 to 1. Multiply it all out, you would come up with 6.598 grams of CO2. That's what you would get here in this scenario. So again, what is my theoretical yield? The one that is predicted to make less. So now I just simply take that number, plug it in down here, multiply it out, and you would come out to 92.0% yield. Right? All right. So again, calculate your theoretical yield, which we've been doing over and over again already. Plug that into your equation. Toughest part about these problems is being able to identify your actuals versus your theoreticals. That's usually one of the trickiest parts here. So again, look for the verbiage, look for the way the problem's worded to try to pull out the actual, but the actual will always be given to you. All right, so now here's practice problem 2. Go ahead and pause the video. This is a great problem to start you from start to finish, to make sure you are ready to go on these kind of problems. So go ahead and pause the video, try this yourself, but this should recall information from last unit and before Christmas and all that we've been doing in this unit. When you're ready, replay the video and I'll show you how to do it. Okay, so as we get started here, we need to read the problem. Phosphorus reacts with bromine or bromine to form phosphorus tribromide. If 35 grams of bromine are reacted and 27.9 grams of phosphorus tribromide are formed, what is the percent yield? So again, we're doing a percent yield equation, so it's actual over theoretical. That's my overall goal here. So I'm going to do that down here on the bottom, but I got to get some things set up. And again, reading this problem, I'm a visual guy. I like to set it up. But we also know that right off the bat, we have to form a chemical equation. So we need to say phosphorus is going to react with bromine, our diatomic, and it's going to produce phosphorus tribromide. Now we need to go back and balance it. I need a 3 and a 2 and a 2. Now for me, I like to even set it up even further. Here I have 35 grams of bromine. And when it says in 27.9 grams of phosphorus tribromide are formed, this is actually giving me the actual. That's the actual. It says it's formed. Remember, the actual will always have to be given to you in the problem. The theoretical is what you calculate. So I want to put a question mark here in grams because this is what I need to calculate. And then down here, I'm going to go ahead and put 27.9 grams because that is the actual they gave me. So now all I simply have to do is convert from here to here, plug that number in here, and we are finished. So again, write down what you know, follow those units, convert that to moles, follow your units. I'm going to go from mole of bromine to moles of bromine or phosphorus tribromide. And then we need to convert our moles of phosphorus tribromide to grams of phosphorus tribromide. This comes from my periodic table, which would be 159.80. This is 3 of these, makes 2 of those. And now again, 1 of these, looking at your periodic table, comes up with 270.67 grams of that. So now when I put that in my calculator, this comes out to 39.52 grams of phosphorus tribromide. This is your theoretical yield, and that value now goes down here. And when I put it in my calculator, it would simply come out to 70.6%. So the new concept here is a very simple idea. I'm going to give you a wordy problem. You're going to have to be able to do what you've been doing all along, write out the chemical equation, do the stoichiometry, and then you have to be able to pull out the actual value from that problem. But then other than that, you just take the number you've been calculating all along, plug it in the equation, do a simple division times 100, and there's your answer. Again, remember sig figs here determines my sig figs here, and that's all I got for you guys. So again, as we look through here, the actual yield is what you're going to produce in real life in an actual lab experiment. Your theoretical yield is what you calculated. It's what's on pen and paper. It's the math you did using stoichiometry. And the percent yield is just simply the actual divided by theoretical times by 100. I hope you guys have a great evening. Bye.